All right, everyone. We had started with exercise 10.5. We were discussing second question. Let's just go over what we have and then solve. You have been given that in a circle, there is a chord whose length is equal to the radius of the circle. You have to find out what will be the measure of the angle that chord subtends on the major arc and on the minor arc. So I have just drawn a circle here with center O. AB is the chord which is equal to the radius of the circle. If we say that the radius is R, then the length of chord AB will also be equal to R. I have taken a point P on the major arc and a point Q on the minor arc. The angle subtended by chord AB at P will be APB. So I need to find out this angle. The angle subtended by chord AB on the minor arc will be the angle AQB. That means I need to find out this angle. If you observe closely, all these 4 points, A, P, B, Q, these 4 points lie on the circumference, which makes the quadrilateral APB a cyclic quadrilateral. This is one observation you can make from here. If you are able to find out either of the two angles, अगर आप APB फाइंड कर लोगे, आप cyclic quadrilateral की property use करके AQB फाइंड कर सकते हो. Or if you can find out AQB first, you can use the same property to find out APB. I hope you remember what the property is. In a cyclic quadrilateral, the sum of the opposite angles is 180 degrees. Now, in order to find out this angle, angle APB, which is angle subtended by AB at the circumference, we would like to use a degree measure theorem, but degree measure theorem relates the angle subtended on the circumference with the angle subtended at the center. So we would like to find out what is the angle subtended by the chord AB at the center. And for that, I want to join the endpoints of the chord to the center. If somehow I can find out this angle, if I can find out angle AOB, I will be able to find out APB using degree measure theorem. And to find out AOB, I'm going to use the property given to me that the length of the chord is equal to the radius of the circle. If you observe closely, triangle AOB.
Equilateral.
It is an equilateral triangle because all three sides are equal to the radius of the circle. OA and OB already are the radii, whereas AB, the chord, is also given to be equal to the radius. So this makes your this makes your triangle equilateral, and hence each angle will be 60 degrees. The angle subtended by the chord at the center will be 60 degrees. With the help of this angle, we can find out APB by applying degree measure theorem. So let's just write this answer. I want you to draw the figure for this one, and I'm going to write down what's given to us. We don't have to prove anything, so I've not written that way. I can simply write down each equals to R. R represents the radius of the circle here. This implies triangle OAB or AOB is an equilateral triangle. Therefore, each angle will be equal to 60 degrees. We are not concerned with all three angles. We only want the angle at the center. So we are just using that. You can write down that each angle will be equal to 60 degrees. And now I'm going to apply degree measure theorem. The angle subtended by the arc AB at the circumference and the angle subtended by the same arc at the center. The relationship will be given by this expression here. AOB equals to twice APB. You can use the value of AOB and find out APB. If you want, you can write down that arc AB subtends angle AOB at the center and angle APB on the remaining part of the circle. This is one of the angles we wanted to find out. In order to find out the second angle AQB, I'm going to use the property that these 4 points lying on the circumference form a cyclic quadrilateral. Now in this case, we have just identified by observing that the vertices lie on the circumference. इस quadrilateral के जो चारों vertices हैं, they all lie on the circumference of the same circle. So the quadrilateral formed will be a cyclic quadrilateral, and hence sum of the opposite angles will be 180 degrees. Is it done?
Yes, ma'am.
No, ma'am.
Okay. Draw the figure for the next question if you have completed this one.
Ma'am, done.
So you've been given this figure in question number 3, 10.37. You can see points PQR on the circumference. Angle PQR is given as 100 degrees. You have to find out angle OPR. So in this figure, it's a little bit inconvenient to observe how this angle is formed. I've drawn the figure. You can also draw it little, like the line segment PR can be drawn a little farther from O. It will be easier to see which angle we want to find out. This is the angle we want to find out. Or let me just represent it with X. This is the angle I want to find out. Given to me is PQR. O is the center of the circle. Nothing else is given as such, only the figure is given. You have to just observe that if O is the center and there is this angle subtended at the circumference, what will be the angle OPR? So I've been given a circle with center O. You can write down points P, Q, R lie on the circumference. Along with that, angle PQR is given as 100 degrees. I want to find out angle OPR. There will be a few things we will be doing in this question. That's correct. We can apply degree measure theorem. We have arc PR subtending an angle at the circumference. I'll just mark that, this angle. This is the angle at the center. And this here is the angle at the circumference. So you can relate these two and find out angle POR. Angle POR will be reflex angle. It's clearly visible from the figure. So I would like you to write down like that. This is the third case of your degree measure theorem. So we can find out angle POR using degree measure theorem. But how does that help us to find out X?
Triangle POR is isosceles.
That's right. Triangle formed here, the one which contains X. Just triangle में X contained है. That triangle is an isosceles triangle. We have a radii of the circle. So angles opposite to these two sides will also be equal. I have represented angle OPR by X. If this triangle is isosceles, that means angle ORP. This angle will also be equal to X. And now if I have this angle, the one which is outside, this reflex angle, with the help of this angle, can I find out the angle on the other side?
120, 140
degrees.
160 degrees.
160 degrees. That's right. I can use the measure of the complete angle in order to find out the angle POR, which is an angle of triangle POR. And then I can apply angle sum property. So I will be doing 2-3, I think, things here side by side. First of all, I'm going to use degree measure theorem. With the help of degree measure theorem, I will be able to find out the angle subtended at the center by arc PR, which is a reflex angle. And with the help of this reflex angle, I can find out angle POR, which is one of the interior angles of triangle POR. And the advantage of doing that is triangle POR is an isosceles triangle, and then I can apply angle sum property in order to find out X. Let's write down and then see if that helps. This is the first step that I'm doing here. Now with the help of this reflex angle, I'm going to find out the measure of angle POR. This will be 360 degrees minus a reflex angle POR. This is the interior angle of triangle POR. So this is the measure of the angle that you require here. Just note this down and go over the answer and let me know in case there is any step you don't understand. We'll discuss that again. Is it done? Shall we take up the next question?
Yes, ma'am.
Anyone with any doubt in this answer?
No, ma'am.
Thank you, Rohan. Question number 4. Question number 4, you have been given the figure for this one as well, figure 10.38. As you can see, there are 4 points on the circumference. I had joined these actually, which is not required. So let's just observe and see what's given to us. 4 points on the circumference and there are these 2 angles given to us. Please observe the angles carefully, which angles are given. थोड़ा सा भी अगर आप slightly इसको ignore कर दोगे, I mean like you would be able to just mark it in the wrong way. It's ACB, not DCB. The difference is very almost negligible. So be careful when you draw the figure. So you have been given angle ABC as 69 degrees, ACB as 31 degrees. The angle that you want to find out here is this one. So we would like to find out a relationship between these 2 angles and angle BDC so that we can write the answer.
Angle BAC equals to angle BBC.
That's correct.
Yes, ma'am, because BC is the chord which subtends the angle and the remaining part of the circumference.
Yes, that's right. We will be using the relation or the result that angles in the same segment are equal. So we have a chord BC here. So as you can see, chord always divides your circle into 2 parts, the segments. जो points A or D हैं, the points A and D both lie in the same segment. So they are lying on the same major arc and the angle subtended by this chord at each of these points will be equal. And we simply write down that the angles in the same segment are equal. So BC is subtending 2 angles on the circumference. सेम कॉर्ड 2 एंगल्स सबटेंड कर रही है, एक A पॉइंट पे और एक B पॉइंट पे. These 2 angles will be equal. So angle A will be equal to angle D. If we can find out angle A somehow, we will be able to find out angle D. अगर हम BAC find कर लें, we will be having the measure of angle BDC. So instead of focusing on how to find out BDC, now we would like to focus on how to find out BAC.
Angle sum property of triangle.
That's correct.
ASP.
For this, we will be using angle sum property in triangle ABC. This is as simple as that. Let's write down the answer. The questions where you have to find out an angle, you can avoid writing that given thing. अगर आप नहीं भी लिखोगे तो भी ठीक है. That is required when you're writing down a question where a result is to be proved. But as for this question, you can directly proceed with your answer. So angle BDC is actually equal to angle BAC here. These are angles in the same segment. And in triangle ABC, we will be applying the angle sum property in order to find out BAC.
BAC 80 degrees.
So this gives you angle BDC also equals to 80 degrees. You can mark if you want, these two angles will be equal. I think the next set of question is all application based. I think till 6th question, 7th question probably. Anyone who's writing down?
No, ma'am.
Question number 5th. Figure 10.39. There are 4 points on the circle A, B, C, D. The line segments AC and BD intersect at E. You have been given the measures for angle BEC and DEC. DCE. You have to find out angle BAC. This is the angle you want to find out. So again, you will be focusing on how to find out or what's the relation that exists between this angle and the ones which are given to you.
BAC equals to BDC.
Okay, BAC is equal to BDC. Again, these are angles in the same segment. So instead of focusing on how to find out BAC, we will be now focusing on how to find out angle BDC. Can we find out this angle?
Angle DEC will be equals to 50 degree, then we can apply angle sum property.
You can find out the angle linear pair, making a linear pair with 130 degrees, and then you can apply angle sum property in triangle EDC. Or you can directly apply exterior angle property.
Exterior angle property.
And then you can find out this angle. So both ways are correct. There will be just one step extra if you go with that linear pair property and then find out this angle D, or you can directly apply exterior angle property and then find out this angle, and angle BDC will be equal to angle BAC. Right? Let's write down the answer. So again, it's a solving question. So we are not going to write down what's given, what is to be calculated. I'm going to write down the answer directly. So I'm just going to mark which I observed here. I have to actually find out BAC. But this angle is equal to angle BDC. These are angles in the same segment. And to find out angle BDC, I'm working in triangle EDC. Exterior angle BEC will be equal to angle EDC plus angle DCE. Those who are not aware of exterior angle property, I mean like forgotten or not remember it correctly, this is the triangle that we have. 130 degrees over here, 20 degrees over here. So this is the exterior angle. The measure of the exterior angle of a triangle is equal to the sum of interior opposite angles. So angle 130 will be equal to this angle at D plus 20 degrees. So if we go back to the original relation, we will have angle BAC equals to 110 degrees. Question number 6, for this one, the figure is not given. You'll have to draw on your own. And this question actually has two parts. You will solve it one by one. Don't try to solve it all together. ABCD is a cyclic quadrilateral. So you want to draw a circle, take 4 points on the circumference, draw that quadrilateral. The diagonals intersect at point E, not necessarily at the center. You have been given DBC as 70, BAC as 30, find BCD. So this is first part. Till here is your first part. Once you have done this, then you will take this condition as the second part of the question. If in the same figure AB equals to BC, what will be the measure of ECD? Let's draw the figure and then we will see what's given to us. So quadrilateral ABCD, the diagonals intersect at E. Make sure you mark the points either clockwise or anti-clockwise. So ABCD, then diagonals intersect at E. Angle BAC is given as 30 degrees. I have marked here. Angle BAC is given as 30 degrees and angle DBC is 70 degrees. The angle you want to find out is angle BCD. You want to find out this angle. This is an angle of a cyclic quadrilateral. If you can find out the angle opposite to it, complete angle A, if somehow you can find out angle A, you can find out angle C, because these two will be supplementary. Now focus
Or
on...
we can say angle BAC equals to angle BDC.
Yes, that's right.
Then we can apply ASP.
That's right. That's right. You can do that way also. Any other person who can think of doing this in some other way? This is one of...
Angle CBA is equal to
CBD equals to angle CAD.
Yes, that's right.
alternative angles.
These will not be alternative angles because we do not have parallel lines. These will be angles in the same segment. Actually, the same relation can be used for the angle 30 degrees with the help of this arc. Agar aap focus karte ho on arc BC is making two angles on the circumference. Observe.
Excuse me, ma'am.
Yes, Taran?
Ma'am, can we say that DEB is the diameter of the circle?
We cannot say because it's not specified. If you compare question number 6th and question number 7th, you will be able to see the difference. In this question, they are just simply saying that the diagonals intersect at E, whereas in 7th question, they have specified that the diagonals are diameters. In that case, they will be passing through the center. वहां पे specify किया हुआ है that the diagonal is diameter. Here we cannot assume that on our own unless it's mentioned. If they said that the point of intersection is the center of the circle, then the diagonals would be diameters. CBD and ADB. No, not actually.
CBD and CAD.
Yes, CBD and ADB are not equal. You cannot take these two equal. These are not alternate. We are not given any set of parallel lines. You cannot use those properties, corresponding or alternate interior. That cannot be used here. The only thing you can use here is either the angles which are formed in the same segment, they will be equal, or you can use the property if you had a diameter. Like the results that we did right before this exercise. जितने रिजल्ट्स आपने इस एक्सरसाइज से पहले किए हैं, डिग्री मेजर थ्योरम की है आपने, साइक्लिक क्वाड्रिलेटरल के बारे में पढ़ा है, angles in the same segment, angle in a semicircle. So those are the results which can be applied in this question if required. So right now, the only thing that's occurring to me is angles in the same segment. And how do we identify that? If you observe chord BC, अगर आप इस chord की बात करते हो, this is making two angles on the circumference. BC subtends two angles on the circumference at A and at D. Those two angles will be equal. So that means angle BAC will be equal to angle BDC. Or you can focus on chord chord CD actually. Chord CD is subtending two angles at the circumference.
Angle DAC equal to angle DBC.
That's correct. Points C and D are also joined to 2 points on the circumference. That's the easiest way you can identify. At A, the angle banega CAD, and at B, CBD. So you can use either of the two relations and then you will be able to see what will happen next. First of all, we observe this, either the first one or the second one. So Saloni has actually mentioned both. I think Taranpreet has also mentioned the second one, that we can say that angle BAC is equal to angle BDC, though this angle becomes 30 degrees. This angle and this angle, they become equal. Or if we use this one, CAD becomes equal to CBD. In that case, this angle will be equal to this angle. This angle becomes 70 degrees. So with either of the two, either the first relation or the second one, we can find out angle C. Agar hum is triangle pe ab concentrate kare, we can use angle sum property in order to find out this angle. Or you can apply the property that this is a cyclic quadrilateral. The opposite angles will be supplementary, and angle A and C, their sum will be equal to 180 degrees. From there also you can find out angle C. All right, let's just go over the answer once again. Let me just. This is what's given to you, a quadrilateral which is cyclic, means the four vertices lie on the circumference. When you draw the diagonals, the point of intersection is E. Two angles are given to you as I have marked. With the help of these two angles, you have to find out this angle. This is the one we need to find out. The question is, find out what will be the measure of angle BCD. What we can observe from here is, जो angles आपको यहाँ पे marked दिए हुए हैं, for which the measure is given to you, 30 degrees and 70 degrees. First of all, identify which chord or arc is subtending those angles. The first option that we could have used is degree measure theorem. डिग्री मेजर थ्योरम तो सिर्फ तब यूज होती अगर हमारे पास सेंट्रल एंगल होता और सरकमफेरेंस वाला एंगल होता. वो यहाँ पे नहीं हो रहा, सिर्फ सरकमफेरेंस पे एंगल बन रहे हैं. सेंट्रल एंगल किसी भी केस में नहीं पॉसिबल. So we cannot use degree measure theorem. After that, we proceed to the possibility of using any of the remaining results, out of which one is angles in the same segment. तो अगर आप वो अप्लाई करने की कोशिश करते हो, this is a chord of the circle. This divides your circle into two parts. On this segment, in the major segment, there are 2 points on the circumference. एक A है और एक B है. When you join the end points of this chord with these 2 points on the circumference, एक ही angle बनता है और दूसरा angle बनता है this one. These two angles will be equal. These are angles in the same segment. So if you go back to your figure and observe, this particular angle is 70 degrees. It will make angle CAD also 70 degrees. This is one possibility. The other possibility is if you focus on chord BC. This chord subtends an angle at A. This is 30 degrees. The same chord is subtending another angle at D. These two angles will also be equal. All right. And either of the two will help you like use a different result. अगर हम इससे work out करते हैं, like we just use this, that chord CD is subtending angles CBD and CAD on the circumference. These will be angles in the same segment and they will be equal. Then what happens is, completing the figure, we were given that this angle is 30 degrees. Now I can say that angle A and C are supplementary. These are opposite angles of a cyclic quadrilateral. And from here you can find out angle C. This is one way. This is first method. Or if you were doing this, agar aap is tarah se karte, and then if I completed the figure, now this angle is 70. I could have used angle sum property in triangle DBC to find out angle C. So you can do any one of the two, whichever seems convenient to you. This will be the first part. After this, you are given that in the same figure, once you have found angle BCD, I think this comes out to be 80 degrees.
Yes, ma'am.
Okay, this comes out to be 80 degrees once you have done this. They are further saying that in the same figure, if AB is equal to BC, if you read the question, they are saying further, if AB equals to BC, then find out ECD. So I'm just going to mark that in the figure, AB equals to BC. Now I want to find out this angle. Sorry, the other one. I want to find out this angle.
Angle ABC is isosceles and
Yes.
angle ACB equals to 30 degree.
In triangle ABC, the two sides are equal. This becomes isosceles triangle. Angle BAC is given as 30 degrees. So what will happen? This angle over here will also be 30 degrees. And now I can just use answer from first part. This angle
30
C
plus
is
x
80.
equal to 80 degree, x equal to 50.
That's right. The total angle C minus 30 degrees will give me the one I require. Anyone with questions before we write the answer? All right. Now I'm just going to use the one I have already written here. Do you have a preference? Like, do you want to use the first one or the second one?
Cyclic quadrilateral.
Okay, let's just use this then. Let's just complete this question and then you can go. This is the answer for the first part. If AB is equal to BC,
Ma'am, I can't hear you.
because I'm not speaking, Prashampreet.
Okay.
That will be
Okay,
all
okay.
with this question, yeah. I hope you've written. If you've written, let me know, then I'll end the meeting. Anyone who's writing down?
No, ma'am.
All right, I'll see you all in the next class.
Thank you, ma'am.
Thank you, ma'am.
You, ma'am.
Thank you, ma'am. Have a nice day.
Thank you, ma'am.
Thank you, God bless you.